In this topic, we are going to cover sockets. A socket is a bidirectional communication channel. You can send data and you can receive data, and sockets can communicate within a process, between processes, or between different systems on a network. For this lesson, we will be focusing on TCP connection-oriented networking sockets. However, we can use the same socket library for other protocols too, such as UDP. The socket library is part of the standard Python library, so we don't have to install anything with pip, we can just start using it. So we can import socket, we can save this, sockets demo.py. And let's start by using the socket library to identify the IP address of a server by using get hostname. So we can say IP equals socket.get by hostname 247ctf.com. Then we can print out that IP address. Get host by name rather. And we can see the IP address here for the host 247ctf.com. And as well as resolving IP addresses, we can also create a socket specifying parameters for the type of socket we want to use. So let's create our socket. S equals socket.socket, socket.af init, socket.sockstream. And the first parameter here, af underscore inet, is the transport mechanism. So we want to be using IPv4 here. And here, as the second parameter, we're specifying sock underscore stream for a connection-oriented protocol because we want to be using TCP. And now that we have a socket object, we can choose what we want to do with it. We can bind the socket to a port and then listen on that port for a connection, or we can use the socket to make an outbound connection to another system. And to make an outbound connection for the AF underscore inet address type, a host port pair is required. The host is a string representing either a host name or an IPv4 address, and the port is an integer. So let's connect to 247ctf.com on port 80. And then once we are connected, we can send and receive data via this socket. So we could say s.sendAll, and we might want to send a head request. And a head request is just a get request without a message body. And after we've sent this head request, we would want to receive the data as the response. So we could say print out the response, socket.receive 1024 bytes, decode that. And here, 1024 is the maximum amount of data which will be received at once, but it doesn't necessarily mean that we will always receive 1024 bytes of data here. And once we're done with our socket, we can close it. We can execute this. And here we can see we've opened up a socket connection to this host. We've then sent a head request to the host, and we've received this data in response, which is a 301 redirecting us to a secure connection. And if we didn't want to just connect to an already existing socket, we can also create and bind another socket to listen for a connection. And depending on the protocol that you're using, for this to work, you typically need to have both a server and a client component. The server waits for connections, while the client initiates connections. So let's add the ability to have both a client and a server. We can specify some port for our socket, 8080. Let's create another socket because we've closed our old one. And let's first start by creating our server. So we could say if server, and if we're a server, we want to be listening for connections. And in order to do that with sockets, we need to use the bind method. And the bind method binds the socket to the specified address. So we could say socket.bind to our local host on the port we specified. And we're just using the local host here, but this can be any available interface. And next, we want to listen for connections. And so now if we run this, let's add a pause here so this doesn't die. An input rather. And now if we open up another command and take a look with netstat, we can see here that our socket is now bound to this address on this port, and it's listening and waiting for connections. So now we need to add a way to handle these connections. So let's create an infinite loop here, and let's accept connections on our socket. And with accept, the server will accept a connection by blocking and waiting for incoming connections here. And the return values from accept are a pair of a new socket object. And these are usable to send and receive data to the other end of the connection. So that would be the client connecting to the server. And so now that we have a connection here, we could send some data. So we might want to say, you made it to the socket. And so this would transmit this message over the socket, and then we could close it. We can execute this. And so now we're in this infinite loop, and our application is waiting for somebody to make a connection. And we can first test this by using PuTTY to connect to the socket and verify that the server is working as expected. And PuTTY is just a terminal emulator, serial console, and network file transfer application. It supports several network protocols, including raw socket connections, which is exactly what we need. So let's download it, PuTTY, from putty.org. We'll just get the standalone version for now. And now that we've downloaded PuTTY, we can make the connection. So let's connect to our local host on our specified port of 8080. And we want to make a raw connection to the socket. And we want to specify here to never close the window on exit, because otherwise, after we close our connection, we'll lose our PuTTY window. So we can execute this. And we can see here, as expected, we get the message in our socket, you made it to the socket, and then we close the connection. And so this is useful for testing, but we can also use Python to connect to this socket too. So we can implement our client mode, if client. So if we're a client, we instead want to connect to the socket. We want to print out the data that we receive. And we want to close the connection. And so our server is already running here. So we don't need another server. This time we want to use the client. And execute sockets demo. And here we can see the message received via our socket. You made it to the socket, which is being sent from our server here. And we can see and verify the connection in Wireshark as well. Wireshark is a packet analyzer used for network troubleshooting and analysis. So we can use Wireshark to analyze our packets and view the connections on the wire. When working with sockets, Wireshark is an invaluable debugging tool. So let's download Wireshark as well from wireshark.org. And now that Wireshark has downloaded, we can install it. And now that Wireshark's installed, we can launch the application. And we can listen on our loopback interface. We can specify our port, which is 8080, as a filter. And now we can initiate our connection again over our socket. You made it to the socket. And here we can see these packets, which were sent over the wire, have been captured by Wireshark. And we can follow this TCP stream, and we can see you made it to the socket. So here, we're just verifying that this data is being sent via a socket over the network. And even though in this lesson, we're sending and receiving data on the same machine, on the same 127.0.0.1 interface, this same method can be used to connect to sockets on other remote systems. And we can also use sockets to connect to any ports we choose. So for example, we could use the socket library to create a port scanner. The idea of a port scanner is to just run through a list of ports, try to connect to each of them, and in doing so, test whether that port is open. And with our port scanner, we will just attempt to connect to various ports and do nothing else. If we're permitted to connect to the port, then we can assume that the port is open, or at the very least, it's accepting connections. So let's specify false here as well, because we don't want to be using our client server component anymore. We can say for port in, and let's iterate over some common ports, 22, 80, 139, 445, 443, and 8080. And now for each of these ports, we want to create a socket. We can specify the default timeout for these sockets. So we only want to wait for 1 second rather than hanging for a longer period of time trying to make our connection. Next, we want to know the result of attempting to connect. And let's just again connect to our local host here. And connect_ex is like connect, which we've used before, but this method returns an error rather than raising an exception. And the error indicator is 0 if the operation succeeded. So this is a bit easier for us to handle in our script, because we can say if result is equal to 0, then we could print out is open for that port, and otherwise we can print out that the port is closed. We can close our socket. And so we can execute this. And here we can see our port scanner in action. So in this virtual machine, port 22 is closed, port 80 is closed, 139 is closed, and 443 is closed. However, 445 is open, and 8080 is also open, which is our server waiting for connections. And networking and sockets are large and complex subjects. We've only talked about simple, connection-oriented TCP sockets in this lesson, but there is a lot more to learn about Python sockets, and I encourage you to read the official socket documentation for this module. But that's it for now, and in the next lesson, we are going to cover Scapy.